Look up at the night sky. What if what you see is just a sliver of what's really there? Imagine a young child perched on a hill beneath the ink-black veil of night, peering through the lens of an old telescope. His eyes are filled with stars, tiny pinpricks of light, scattered across the velvet sprawl of the cosmos. But what mesmerizes him most is not the stars themselves, but the darkness that stretches between them, an abyss of invisible mystery. This child is not alone in his fascination. The world's great scientists share his curiosity, for this darkness holds the secrets of the universe. This is the realm of dark matter and dark energy, the unseen components making up a staggering 95% of the universe. How do we know it's there if we can't see it? It's like feeling the wind on your face. You can't see it, but you can see its effect. You can see the leaves rustling in the trees, the waves rolling onto the shore. In the same way, we can't see dark matter and dark energy, but we can observe their influence on the visible universe. The story begins in the 1930s with a Swiss astronomer named Fritz Zwicky. He was studying the Coma Cluster, a massive group of galaxies. Zwicky noticed that the galaxies were moving too fast, so fast that they should have been flung out into space. But they weren't. Something was holding them together. Zwicky proposed there must be unseen mass, or dark matter, at work. And then there's dark energy. Scientists observing the universe in the late 20th century realized it was not only expanding, as Edwin Hubble had discovered in the 1920s, but the expansion was accelerating. Something was pushing the galaxies apart. That something is what we now call dark energy. But what does all this mean for us, you might wonder? Well, it means that our cosmic story is mostly unwritten. We are like children reading a book with only a few pages illuminated. The rest are shrouded in darkness. We have just begun to explore the invisible universe, and every discovery will redefine our understanding of our place in the cosmos. The fact that we can't see dark matter and dark energy doesn't make them any less real. We still feel their effects, like the pull of a magnet or the warmth of a fire. They are the unseen forces shaping our universe, crafting galaxies, catalyzing cosmic expansion. They are the architects of the cosmos, painting on a canvas we can't yet fully see. The child on the hilltop gazes into the telescope, his eyes wide with awe and wonder. He knows now that the darkness is not empty, but filled with invisible matter and energy. He feels small, humbled by the vastness of the unseen. But he is not discouraged. He is inspired. Think of the child as you gaze up at the night sky. We are all children, standing on the edge of the known universe, peering into the unknown. We may be small, but we are not insignificant. We are explorers, pioneers on a cosmic journey. We are the ones who dare to ask, what if what we see is just a sliver of what's really there? And we are the ones who will venture into the darkness to find out. So let us look up at the night sky with a sense of wonder and humility, ready to explore the vast unseen. For the universe is a grand mystery, and we are but humble stargazers, poised on the brink of discovery. The cosmos is our canvas, and we are only beginning to paint. As the allure of high-temperature superconductivity beckons, you may notice a sense of excitement, a curiosity that tingles, much like when you watch a magician perform a trick. The world of physics, much like the world in your dreams, is full of mystery and wonder. As you delve into the enigma that is superconductivity, you might find your eyes growing heavy, your mind becoming quiet and clear, a sense of peace enveloping you. When you think about the potential of superconductors, your mind might start to wander, to imagine the possibilities. And as you do, you might notice the rhythm of your breathing slowing down, the weight of your body sinking into your seat. It's as if you're watching a movie, absorbed in the story, feeling the words wash over you. As we return to the quest of understanding high-temperature superconductivity, you might find yourself drifting, your attention ebbing and flowing, much like the electrons in a superconductor. The mysteries of the universe can be as mesmerizing as the gentle sway of a pendulum. You may even notice your eyelids becoming heavy, a pleasant sense of relaxation taking over. As you read about the scientists tirelessly researching this phenomenon, you might find a parallel in your own life, perhaps a task that requires patience and persistence, a puzzle that's yet to be solved. And as you think about it, you may notice a sense of calm, a deepening of your breath, a subtle relaxation that spreads from your toes to the crown of your head. In the end, the story of high-temperature superconductivity is a testament to human curiosity and determination, a reminder that every breakthrough, every discovery, brings us closer to understanding the universe. And as you ponder this, you might find your eyes growing heavy, your body sinking into a deep, restful state, much like the peaceful stillness after the climax of a story. As we conclude our journey into the world of superconductors, remember that the path to understanding is paved with patience, curiosity, and wonder. And as you contemplate this, you may find a sense of contentment washing over you, your body relaxing, your mind tranquil, ready for a restful sleep. So as we close this chapter, you may find your eyes growing heavy, your thoughts drifting, your body sinking into relaxation. And just like that, you might find yourself in a state of deep, restful sleep, ready to dream about the enchanting world of high-temperature superconductivity. Imagine you're at the supermarket, standing in front of a row of identical canned goods. You reach out, your hand hovering between two cans of tomato soup. You're about to make a decision, and in that moment, the universe holds its breath. Why? Because according to quantum physics, until you make your choice, both cans exist in a state of simultaneous selection and rejection. Sounds strange, doesn't it? You may notice a slight tingle of intrigue. Welcome to the mysterious world of quantum's measurement puzzle. Let's break it down. In the quantum realm, a particle can exist in multiple states at once, a concept known as superposition. But the moment we measure or observe it, the particle collapses into a single state. It's like those cans of soup. Until you choose, both are potential selections. But once your fingers close around a can, the other is instantly relegated to rejection. How could that be? Can the act of observing or choosing really alter reality? Your eyes blink, heavy with the weight of this thought. You can feel the cool metal of the shopping cart under your hands. Hear the soft hum of the supermarket lights overhead. Take a moment to let it sink in. This idea that your simple act of choice could ripple through the cosmos. Here's the crux. This isn't just an abstract concept. It's the heart of one of the most baffling mysteries in quantum physics, the measurement problem. This puzzle has perplexed scientists since the brilliant Erwin Schrödinger proposed his famous thought experiment. You remember Schrödinger's cat, right? the feline that's both alive and dead, until someone peeks into the box. The implications are enormous. If our observations can shape reality, what does that imply about our role in the universe, about our responsibility to each other and to our shared reality? You may notice your breath slowing, deepening, as you ponder these questions. Your attention might drift, as it often does when we grapple with complex ideas. That's okay. Let it wander. Because here's the thing. Every choice we make, no matter how small, impacts the world around us. When you selected that can of tomato soup, you didn't just determine dinner. You collapsed a quantum superposition. You shaped reality. This isn't just about physics. It's about the way we live our lives, the choices we make every day. When we choose kindness, when we choose to listen, to understand, to help, we're not just making moral decisions. We're shaping the very fabric of our shared reality. And just as you've made your choice in the supermarket, it's time to choose what you'll do with this newfound perspective. Will you let it sink in? Let it weave itself into the fabric of your everyday life. The stakes are high. The choices we make ripple outwards, impacting not just our own lives, but the world at large. And if we can shape reality with our choices, the question is, what kind of reality do we want to create? So, as your eyes grow heavy and your mind buzzes with these thoughts, remember, every choice matters. The universe is watching. And as you drift into a deep, restorative sleep, may you dream of a world shaped by kindness, understanding, and the power of choice. Imagine, if you will, standing in your backyard, looking up at a clear night sky. The stars are twinkling, the moon is glowing, and just when you think it couldn't get any more picturesque, a brilliant flash of light erupts. It's so bright, so intense, it drowns out all the other celestial bodies. For a moment, you think it might be a meteor or a falling satellite. But no, it's something far more inexplicable, something beyond our comprehension. It's a white hole. Wait a minute, a white hole. You've heard of black holes, those cosmic vacuum cleaners that suck in everything, even light itself. But a white hole? Isn't that just the stuff of science fiction? Let's break it down. You're not entirely wrong. White holes do exist in the realm of theoretical physics, but they haven't been proven or observed in the physical universe. Yet, they are essentially the theoretical opposites of black holes, spewing out matter and light instead of absorbing them. How could that be? Well, let's take a step back in time. In 1916, a physicist by the name of Ludwig Flamm proposed the concept of white holes using the equations of Albert Einstein's theory of general relativity. According to Flamm, if black holes exist, then so must their opposites. For every action, there must be an equal and opposite reaction, as Newton's third law states. Now imagine that white hole in the sky again. What would it mean for us down on Earth? The societal stakes are huge. If white holes are real and they do eject matter and energy, then they could potentially alter the fabric of the universe as we know it. That flash of light in your backyard sky could be a sign of a new universe being born or a star system being created. But it's not all doom and gloom. The discovery of a white hole could also unlock secrets of the universe that have remained hidden for centuries. It could lead to breakthroughs in space travel, energy production, perhaps even time travel. Here's the crux, though. Even though the idea of white holes is fascinating, it's still just a theory. Despite all our scientific advances, we're still grappling with the mysteries of the universe, still trying to reconcile the laws of quantum mechanics with those of general relativity. But that doesn't mean we stop trying. Every night, astronomers peer into their telescopes, hoping to catch a glimpse of these elusive phenomena, just like you, standing in your backyard, looking up at the night sky. So, what's the moral of this cosmic story? It's that our universe is full of mysteries, and the pursuit of those mysteries is what drives us forward. The white hole riddle might not be solved in our lifetime, but that doesn't mean we shouldn't try. Because who knows? Maybe one day, the flash of light in your backyard sky will be the first confirmed sighting of a white hole. And on that day, we won't just be observers in the universe, but active participants in its grand story. And isn't that what we all strive for? To be part of something larger than ourselves, to contribute to our collective understanding of the world and the universe we live in. So, keep looking up and keep asking questions. Because every question brings us one step closer to the answers. Imagine for a moment you're sitting in a bustling cafe. The clatter of cups and the murmur of conversation hum around you, but you're lost in your own world. Your gaze is fixed on the steam curling up from your freshly poured coffee as you ponder the unsolved physics mystery of the fifth force Enigma. How could that be? You wonder. A fifth force of nature that we've somehow missed. Let's break it down. You're familiar with the 4 fundamental forces of nature, aren't you? There's gravity, the one that keeps your coffee cup anchored to the table. Then there's electromagnetism, responsible for the light reflecting off the cup, allowing you to see it. The strong nuclear force holds the atoms in the cup together, while the weak nuclear force allows the sun to shine, giving us energy. But a fifth force? What could that possibly be? As you sit there, your eyes may start to grow heavy as you lose yourself in thought. It's the kind of question that's like a mystery novel, full of twists and turns, and you're eager to unravel it. Here's the crux. Scientists believe this fifth force might exist because of anomalies they've spotted in the universe, things that can't be explained by our current understanding of physics. Remember Newton's laws? The ones about action and reaction, about how every force has an equal and opposite one. They seem to be coming up short. You might feel your attention drifting, your breathing slowing down as you consider the implications. If there is a fifth force, it could change everything, not just for physicists, but for all of us. It might explain dark matter, dark energy, the expansion of the universe. It could be the key to untold scientific advances. As the cafe around you buzzes with life, you're struck by the enormity of this. A fifth force could impact everything, from medicine to technology, from how we understand the universe to how we live our daily lives. A single discovery and our world might never be the same. Your mind wanders, picturing the scientists working tirelessly to solve this mystery. You can almost see them, hunched over their work, eyes heavy with fatigue, but burning with determination. Their hard work, their passion, it's all for this, to uncover the secrets of the universe, to make our world better. In this moment, as your thoughts turn to these invisible heroes, you might start to feel a deep sense of gratitude. You may notice a warmth spreading through you, a profound appreciation for the tireless pursuit of knowledge that drives humanity forward. As you finish your coffee, You find yourself reflecting on the power of curiosity, of questioning, of never being satisfied with the status quo. The fifth force Enigma is a testament to that. It's a reminder that there's always more to learn, more to discover. And it's these unsolved mysteries that keep pushing us forward, that keep us striving for a better tomorrow. Isn't it fascinating? The universe is full of mysteries, and we're just tiny specks trying to understand it all. Yet, every discovery, every advancement begins with someone asking a question, just like you in this cafe, pondering the enigma of the fifth force. As the world continues to spin, the sun sets, and you might find your eyes growing heavier, your mind calmer. The bustling cafe fades into a soft murmur, the day's questions and wonders gently settling down. The fifth force enigma remains unsolved, but it's okay. The night invites rest, a deep restorative sleep. Tomorrow brings another day, another chance to unravel the mysteries of the universe. For now, you let your eyes close, your breathing slow. Tonight, you rest. Tomorrow, you explore. Imagine looking up at the star-studded sky, feeling the pulse of cosmic wonder. Your eyes may suddenly grow a bit heavy, your attention may begin to drift, and your breath might slow down just a bit. As you look past the familiar glow of the stars, something unsettling swirls out there. It's an apparent flow of galaxy clusters, all moving in a mysterious direction. They call it the dark flow. An unseen force or distant mass might be tugging on entire clusters of galaxies. How could that be? Especially when cosmic expansion should scatter them in all directions. Now picture a quiet suburban street at dusk. Neighbors stand outside, each house quietly minding its own business. Your eyes might grow heavy again, your attention might drift, and your breathing could slow down. Suddenly, without warning, every third house shifts several feet to the left. No one can see the cause, but they can measure the movement. But remember, this normal neighborhood is dwarfed by the monstrous scale of galaxy clusters, defying standard cosmological models. Scientists notice this unexpected motion in data from the Wilkinson microwave anisotropy probe. It led them to wonder if there's more out there, beyond our observable universe. The expansion of space suggests distant galaxies recede from us in all directions evenly. But researchers found a consistent pull, something unaccounted for by standard gravity or known mass distributions. What if our cosmic bubble is one region among countless others, like neighborhoods in a far vaster city we can't fully see? The dark flow might be a clue that beyond the horizon something beckons. As you contemplate this, your eyes may grow heavy once more. Your attention can drift and your breathing may slow down. In the early 20th century, Edwin Hubble revolutionized our understanding of cosmic expansion. Yet, as with Zeno's paradoxes in ancient Greece, each new discovery often unravels another riddle. Here's the crux. If dark flow persists, it may challenge the assumptions behind our standard cosmological model, the one that tries to unify inflation, dark energy, and galactic distribution. The emotional stakes couldn't be higher. Entire scientific careers ride on, explaining the invisible. Societies invest billions in telescopes and space missions. Students bet their future on unraveling cosmic mysteries, hoping to crack the code that might reveal multiple universes or unknown laws of physics. What if the answer lies in a brand new force or hidden region that pulls with relentless consistency? It's enough to send shivers down anyone's spine. Yet the morale of this cosmic fable is simple. the more we think we know, the more a single speck in the data can upend our worldview. Like neighbors forced to confront a strange phenomenon on their street, humanity looks beyond what is seen and grapples with the intangible forces that shape us. Perhaps we'll one day adapt new theories that unify known physics with the mysterious. Until then, the dark flow remains nature's whispered invitation to keep exploring, never settling for easy answers. As you ponder this, your eyes may grow heavy, yet again. Your attention might drift, and your breathing could slow down. It's all part of the story's texture, a gentle reminder that deeper, more restorative sleep is within your grasp. So relax, sink, rest more profoundly, and keep exploring the cosmic mysteries that our universe whispers to us. Imagine, if you will, the most ordinary of mornings. You're in your kitchen, pouring yourself a cup of coffee. The steam rises, mingling with the soft morning light streaming through the window, and you may notice the comforting rhythm of your own breath, in, out, just like the universe itself. The day's demands have yet to pull you in a myriad of directions. Now, in this quiet moment, consider this. What if everything you see, everything you touch, everything you know to exist, is only a fraction of what's really out there? Here's the crux. It's called dark matter, and it's one of the greatest unsolved mysteries in physics. You can't see it, touch it, taste it, or smell it. But scientists believe it makes up about 85% of the universe. How could that be? Let's break it down. Nearly a century ago, astronomer Fritz Zwicky noticed something peculiar. Galaxies were spinning too fast, and they should have been tearing themselves apart, yet they weren't. Zwicky concluded there must be some invisible stuff holding them together. That stuff is what we now call dark matter. But how does dark matter relate to you, sipping your coffee on this ordinary morning? Well, without it, there might not be a you, a coffee, or a morning to enjoy them. Dark matter, it is believed, is the invisible glue that holds our universe together. Without it, galaxies might not have formed, stars might not have ignited, and life as we know it might not exist. So, why does this matter? Why should you care about something so seemingly distant and abstract as you go about your day-to-day life? You may notice how your eyes sometimes grow heavy as the day wears on, how your attention drifts from one task to another, how your breathing slows as the evening sets in. Each of these moments, each of these experiences is possible because of our universe's harmonious balance. Think about it. The same forces that hold the galaxies together also shape your world. The same cosmic dance that birthed stars and planets also gave rise to the coffee in your hand, the air in your lungs, and the thoughts in your mind. There's a profound interconnectedness in all things, a unity that defies our understanding, yet underpins our existence. Yet, the mystery of dark matter remains unsolved. It floats in the background of our lives, an enigma as elusive as the drifting tendrils of steam from your morning coffee. But perhaps the beauty of our universe lies not in knowing all the answers, but in the endless pursuit of understanding, in the questions that make our eyes sparkle with curiosity and our minds race with possibilities. So, as your day unfolds, remember this. We are all part of a universe far vaster and more mysterious than we can fathom. Our everyday lives are interwoven with cosmic wonders beyond our ken. Each moment, each breath, each beat of our heart is a testament to this grand cosmic ballet, And as the day draws to close, as your eyes grow heavy and your breath slows, remember that you too are a part of this grand mystery. In essence, we are all stardust, guided by unseen forces, journeying together through the cosmos. And in our quest for understanding, we learn, evolve, grow, and dream. We share stories, hopes, and discoveries. Each of us plays a unique part in this cosmic tale, and together we shape its future. So, amidst the hustle and bustle of life, take a moment to marvel at the universe's grandeur, to appreciate its mysteries, and to cherish our shared journey through the cosmos. After all, isn't that part of what makes life truly extraordinary? Take a moment now and imagine being on one of those galaxies drawn towards the great attractor. The immense pull may feel like a gentle tug, guiding you in a certain direction. As you consider this, your mind might wander, floating through the vast cosmos like a small ship adrift in the ocean. You may even notice your breathing slowing down, matching the serene rhythm of the universe. As we journey through this cosmic narrative, your attention might drift from the words, focusing instead on the scenes unfolding in your mind's eye. And as your attention shifts, you may notice your eyelids growing heavier, as if weighed down by the gravity of a distant celestial body. You could blink, or you could just let your eyes close for a moment, if that feels right. There's a peace in this, in surrendering to the pull of the great attractor, to the rhythm of the cosmos. It's like a gentle lullaby that the universe sings, a melody that can put your mind at ease. The more you listen, the more you might feel yourself sinking into relaxation, deeper and deeper. This story we're sharing, this journey across the cosmos, is not about reaching a destination. It's about the journey itself, the gentle pull of the unseen, the gradual surrender to the rhythm of the universe. You are not lost. Rather, you are being guided by cosmic forces too immense to comprehend, but still somehow comforting in their constancy. And as you continue on this journey, you might notice a subtle shift in your perception, an opening of your awareness to the vast possibilities of the universe. You may find yourself drawn not just to the physical realm, but also to the realm of ideas, of dreams, of hopes, and fears. And in that realm, you may discover a deeper understanding of yourself, of your place in the cosmos, of your connection to the great attractor. And as you discover these truths, you may find your body and mind sinking into a deeper state of relaxation, a deeper state of peace. You may notice your breathing slowing down, your heart rate calming, your thoughts drifting away, like galaxies being pulled by the great attractor. And in that peaceful state, you may find a deeper, more restorative sleep waiting for you, a sleep as vast and peaceful as the universe itself. So allow yourself to drift, to be pulled towards the great attractor. Let the cosmic forces guide you. Let the universe sing its lullaby. Relax, sink, and rest. And remember, in the grand scheme of things, you are not just a tiny speck in the universe, but a crucial part of it. And in that realization, you may find a peace deeper and more profound than any sleep. Keep this journey in mind, keep asking questions, and keep searching. After all, the great attractor mystery reminds us there's always more to see, so long as we look beyond what blinds us in the moment. Imagine this for a moment. You're at home, wrestling with a stubborn pickle jar. The jar twists and turns in your hands, the lid refusing to budge. You're putting in quite a bit of effort, your muscles straining, your face flushed with exertion. And yet, just a few feet above your head, the moon, with all its mass and gravity, is pulling gently, almost imperceptibly, at the water in your body. How can that be? Let's break it down. The force you're using to open that pickle jar is a form of one of the 4 fundamental forces of nature: the strong nuclear force, the weak nuclear force, the electromagnetic force, and of course, gravity. But here's the crux. Gravity is by far the weakest of these forces, so weak that you, a single individual, can counteract the gravitational pull of an entire planet with just a casual tug of your hands. But why is gravity so weak? This question, known as the hierarchy puzzle, has been a fundamental conundrum in physics for centuries. Even the great Galileo, who first quantified gravity, couldn't answer it. And it's not just a matter of intellectual curiosity. If gravity were stronger, the universe as we know it, and our lives within it, would be drastically different. Imagine again if gravity were just a bit stronger. Buildings may have to be shorter, lest they collapse under their own weight. You might feel permanently tired, each step a small victory against the pull of the earth. The carefree joy of swinging on a playground, the leap of a dancer, the flight of a bird, all might be impossible in a world with stronger gravity. You may notice your eyes growing heavy as you imagine this world. You might feel your attention drifting, like a leaf on a gentle breeze. It's okay. Let it drift. Breathe in, breathe out, slow and steady. Consider this. We live in a world finely balanced, where we can leap and dance and fly. A world where we can wrestle with pickle jars and win, where the moon can sway the oceans without crushing us. Isn't that wonderful? Isn't that worth preserving? So, what does the strength of gravity have to do with our everyday choices? Everything. The universe is a delicate balance of forces, and so is our world. Our actions, individually and collectively, can tip the balance for better or worse. There's a certain comfort in the rhythm of these thoughts, isn't there? A sense of peace in the steady pulse of the universe, in the gentle pull of gravity. It's like a lullaby, a whispering reminder of the vast, beautiful cosmos that cradles us. A reminder that we are part of something larger, something profound and mysterious. As your thoughts drift through the cosmos, your eyes may flutter shut. It's okay. Let them. Let gravity pull you down, down into deep restorative sleep. Because tomorrow you'll wake up in a world where gravity is just right. A world that's waiting for your touch, your energy, your force. Rest now. Dream of moontides and pickle jars. Dream of the delicate balance of the universe and the power of your own actions. Dream and remember, gravity is weak, but together we are strong. As you contemplate this cosmic mystery, you may notice the soothing rhythm of your own breath, like the predictable pulsing of distant stars. As you take in the words, your eyes might grow a touch heavier, your attention drifting amidst the vastness of the universe. You can imagine the slow, steady expansion of space, much like the calming ebb and flow of your own breath. This cosmic dance reminds us of the gentle rhythm of life itself, a rhythm that can lull us into deeper, more restorative sleep. As we ponder the vastness of space, the mind naturally begins to quiet, like a calm sea under a starlit sky. The gentle hum of the universe becomes a soothing lullaby, inviting us to embrace the peacefulness that surrounds us. You might find your thoughts slowing, your body sinking deeper into relaxation. A soft sigh might escape your lips as you surrender to the comforting embrace of tranquility, allowing yourself to rest more profoundly. As we continue this cosmic journey, your attention may drift like galaxies, adrift in the cosmic current. The slow, steady expansion of the universe could mirror your own journey towards deeper relaxation. You may find your eyes growing heavier, your breath slowing, as you allow yourself to sink into the comforting depths of restful sleep. The Hubble tension, this cosmic puzzle, encourages us to keep refining our tools, not unlike the way we refine our methods for achieving a more restful, rejuvenating sleep. As we continue exploring the wonders of the universe, we might find ourselves drifting deeper into the realm of dreams, a realm where anything is possible. So, as you ponder the mysteries of the universe, you may find your eyes growing heavier, your breathing slowing, your body sinking deeper into relaxation. The gentle rhythm of the cosmos becomes a soothing lullaby, guiding you towards a deeper, more restorative sleep. Much like the universe that continues to surprise us, you might find that the journey towards deep, rejuvenating rest is full of unexpected wonders. As we continue this cosmic journey, remember that the universe is vast and full of surprises, just like our own minds. And just as the universe continues to grow and evolve, so too can our ability to achieve deeper, more restorative rest. So allow yourself to relax, to sink, to drift amidst the stars. Because in cosmic and everyday journeys alike, the more carefully we measure, the more wondrous the world can become. Imagine your favorite pair of socks disappearing into the abyss of your laundry pile, only to never be seen again. Annoying, right? Now imagine if the stuff that makes up everything you see, touch, and feel, a vast chunk of the universe, pulled the same disappearing act. How could that be? Let's break it down. Scientists, those ace detectives of the cosmos, tell us that the universe is made up of matter. You, me, the chair you're sitting in, the device you're reading this on, all of it is matter. But according to our best theories, there's a lot more matter out there than we can see or detect. This missing matter is called baryonic matter, or baryons for short. It's like an enormous cosmic game of hide and seek, with baryons as the elusive quarry. Fritz Zwicky, a Swiss astronomer, back in the 1930s, was the first to notice that something was off. When he observed galaxies in the Coma cluster, moving at speeds that suggested there was more mass present than could be accounted for. Thus, the mystery of the missing baryons was born. As you settle into this thought, you may notice your eyes growing a little heavier, your mind drifting along with the galaxies in the cosmic ocean. But here's the crux. The missing baryons aren't simply an academic curiosity, a puzzle for astrophysicists to ponder over their morning coffee. The stakes are high. If we can't find these elusive baryons, it means our current understanding of the universe, our theories and models, might be fundamentally flawed. It's like trying to put together a jigsaw puzzle, but you're not sure if you even have all the pieces. Can you imagine the frustration, the tension, the sheer existential angst in the scientific community? It's the sock in the laundry all over again, but multiplied by 1 billion and with profound implications for our understanding of the universe. So as your attention continues to drift and your breathing slows, consider this. What if we, in our everyday lives, mirror this cosmic mystery? What if we too are missing parts of our own puzzle, parts of ourselves that we've misplaced, forgotten, or are yet to discover? It's a thought that can make your mind spin, almost as if you're spiraling in a galaxy far, far away. But in this spinning, in this spiraling, there's also a sense of comfort, of connection to the vast, mysterious cosmos. In the end, the story of the missing Baryons is a reminder of our place in the universe. It's a call to curiosity, to the pursuit of truth, no matter how elusive. It's a testament to our collective journey of discovery, a journey that's as much about understanding the universe as it is about understanding ourselves. As your eyes grow heavier still and your mind sinks deeper into the cosmic mysteries, remember this. Each of us, like the universe, is a puzzle to be solved, with missing pieces waiting to be found. And in that search, in that discovery, we find not just answers, but also a deeper, more restorative peace. So as your attention drifts off and your breathing slows, remember the missing Baryons. Let their story lull you into a deep, peaceful sleep, filled with dreams of distant galaxies and hidden cosmic truths. And who knows, maybe in the morning you'll find that missing sock. Imagine a spinning top. Now, imagine that the top is not just a toy, but a fundamental particle, a tiny building block of the universe. Its spin, its wobble, its little dance on the table is not just a plaything of children, but a cosmic mystery that has left the greatest minds in physics scratching their heads. This is the Muon G2 mystery, a puzzle that's as relevant to your everyday life as the clock ticking on your wall or the smartphone in your pocket. You see, the Muon is not any ordinary spinning top. It's a subatomic particle, like an electron, but 200 times heavier. It spins, yes, just like a top, but it also wobbles, deviating from its expected path. And this wobble, this tiny quirk of nature, is what has physicists around the world puzzled. Because according to the standard model of particle physics, the muon should not wobble as much as it does. How could that be? Let's break it down. The standard model, the reigning theory of particle physics, predicts the behavior of all known particles, including the muon. The model works beautifully, explaining everything from the behavior of atoms to the formation of stars. But when it comes to the muon, the model stumbles. The muon's wobble, its G2 factor, is just a smidgen more than the model predicts. It's like a clock that's always a second too fast, or a top that wobbles just a bit too much. Here's the crux. This tiny discrepancy could mean that there are unknown forces or particles in the universe that we have yet to discover. It could mean that our understanding of the universe is incomplete, that we need a new theory, a new model. It's as if Zeno, the ancient Greek philosopher who questioned whether we can ever truly reach our destination if each step is half the length of the last, was whispering in our ears, "Are you sure you've got it right? What does this mean for you, sitting there with your morning coffee, your ticking clock, your smartphone?" Quite a lot, actually. Every advancement in our understanding of the universe has led to practical applications that shape our everyday lives. The quantum mechanics that puzzled Einstein now powers the microchips in your computer. The laws of electricity and magnetism that fascinated Faraday now light up your city. So, the muon mystery might seem abstract and distant, but solving it could revolutionize our world. It could lead to new technologies, new energy sources, new ways of communicating. It could change the way we live, the way we work, the way we understand our place in the universe. And what does this mean for our society, for our collective future? It means that we need to invest in science, in curiosity, in the pursuit of knowledge. We need to support the physicists who are trying to solve the Muon mystery, the students who are learning about it, the teachers who are explaining it. Because in the end, the solutions to our biggest problems, the keys to our future, lie in understanding the world around us, in all its complexity and wonder. In the words of John Maynard Keynes, the difficulty lies, not in the new ideas, but in escaping from the old ones. The Muon G2 mystery is a reminder that we must always be ready to question, to explore, to imagine. Because just as a spinning top wobbles off its expected path, so too can our understanding of the universe take unexpected turns, leading us to new discoveries, new ideas, new possibilities. In the end, it's not just about the Muon. It's about us, our curiosity, our courage, our capacity for wonder. It's about how we face the mysteries of the universe, how we seek to understand our world, how we strive to shape our future, and that surely is a mystery worth solving. Imagine, if you will, a simple everyday scene. You're at the local park, watching your child launch a toy spaceship skywards. The small craft soars, reaching its zenith, and then, as expected, gravity pulls it back to Earth. But what if, just for a moment, the spaceship didn't fall? What if it hung in the air, refusing the call of gravity? How could that be? This may seem like a mysterious scene from a sci-fi movie, but it's actually a real-life enigma in the world of physics known as the Pioneer Anomaly. Much like the toy spaceship in the park, the Pioneer 10 and 11 spacecrafts, when they were launched in the 1970s, exhibited an unexpected slowdown as they ventured away from the sun. This tiny but persistent discrepancy between the predicted and actual speeds puzzled scientists. Let's break it down. The spacecrafts were slowing down more than they should have been, according to our understanding of gravity. Here's the crux. The anomaly seemed to be flying in the face of the laws of physics. Could it be that we had misunderstood something fundamental about the universe? As you ponder this question, you might notice that your eyes have grown a bit heavy. The day has been long, and the peaceful setting of the park, the gentle whir of the distant traffic, the soft rustle of leaves in the breeze, all seem to be whispering a lullaby. Perfectly normal, of course. After all, isn't it natural to feel a bit drowsy when grappling with weighty questions? But let's return to our anomaly. This isn't the first time humanity has been confounded by the universe. Think back to ancient Greece, when Zeno of Elea proposed his paradoxes, questioning the very nature of motion. Or consider the 20th century, when economist Keynes had to grapple with the paradox of thrift during the Great Depression. We faced mysteries before, and somehow we've always managed to find our way. Why does this matter? Well, the Pioneer Anomaly, and other unsolved mysteries like it, challenge our perceptions and push us to grow. They remind us that we're a part of something larger, something infinitely complex and beautiful. And as we stand in the park, watching our children play, we can't help but feel a sense of awe and wonder. As you consider this, you might notice that your breathing has slowed. The park, with its serene ambiance, has a calming effect. It's as if the world is slowing down, matching the pace of your thoughts. Fascinating, isn't it? How our surroundings can mirror our internal state. In the end, it all comes down to curiosity. The desire to understand, to explore, to question. It's this curiosity that led us to launch Pioneer 10 and 11 into the vast unknown reaches of space. And it's this same curiosity that will lead future generations to continue the quest for knowledge. So what's the takeaway? Perhaps it's this. The universe is full of mysteries, and that's okay. We don't have to have all the answers. In fact, sometimes the questions are more important. They push us to explore, to learn, to grow. And who knows? Maybe one day your child, inspired by that toy spaceship in the park, will be the one to solve the next great mystery. And as you muse over this thought, you may find your attention drifting, your eyes growing even heavier. It's been a long day, filled with big questions and small wonders. Perhaps it's time to rest, to recharge, to dream of tomorrow's adventures. After all, the mysteries of the universe will still be there in the morning. They can wait. For now, it's time to rest. Just rest. The proton radius puzzle, a fascinating conundrum in the world of physics, serves as a perfect example of the unexpected mysteries that lurk within the known universe. This puzzle, you might find, is not unlike the hidden complexities of your own mind. As we delve deeper into this scientific anomaly, you may notice an inherent tranquility in the pursuit of knowledge, a soothing rhythm in the oscillation between understanding and mystery. In the world of physics, as in the world of the mind, there are constants and variables. For ages, the size of the proton was considered a constant, a given. But then the Muon-based measurements threw a wrench in the works, suggesting a smaller radius for the proton. This unexpected discrepancy, you might realize, has the power to disrupt the stability of well-established equations, much like a sudden insight can change the course of your thoughts. The revelation that the proton might be smaller than we believed doesn't just stir things up in the world of physics. It also opens up a world of possibilities for deeper understanding and new discoveries. Just as you may find yourself seeing things from a fresh perspective, when you question your assumptions, this revelation invites physicists to revisit their understanding of protons and muons. As we explore the implications of the proton radius puzzle, you might notice a slight shift in your attention, a gentle pull towards relaxation. The rhythm of the narrative, the unfolding of the mystery, might lull your senses into a state of calm. As you ponder this scientific conundrum, your eyes might grow heavy, your breathing might slow down, and your attention might drift. As the story unwinds, you might find yourself sinking deeper into the narrative, savoring the subtle suggestions that are woven into the fabric of the prose. The proton radius puzzle, this intriguing anomaly in the world of physics, might serve as a gentle lullaby for your mind, lulling you into a deeper, more restorative sleep, just as the proton radius puzzle prompts physicists to question their assumptions and make room for the unexpected. This narrative invites you to do the same. It's a gentle reminder that there's always room for the unexpected, both in the world of science and in the world of your mind. And in that sliver of uncertainty, you might find new insights, new discoveries, and a deeper sense of rest and relaxation. Imagine, if you will, standing in your kitchen, making a cup of coffee. The rich aroma fills your nose as you watch the dark brew trickle into your mug. It's a simple, everyday moment, isn't it? Now, what if I told you that this seemingly straightforward scene is actually underpinned by an unsolved mystery of physics known as the vacuum catastrophe? Intrigued? Let's break it down a bit. At the heart of the matter is a concept we take for granted every day: empty space. You may notice, as you reach for your coffee, the space surrounding your hand. Empty, right? Well, not quite. According to quantum field theory, this empty space is actually teeming with virtual particles constantly popping in and out of existence. But hold on, you might think. How could that be? The key lies in the energy of the vacuum itself. The theory predicts this energy to be incredibly, unimaginably high. Yet when we observe the universe, we find it to be practically zero. Here's the crux. This discrepancy, known as the vacuum catastrophe, is one of the greatest unsolved problems in physics today. And it's right there in your kitchen, nestled between your hand and your coffee cup. You may notice, as you grapple with this concept, a sensation of your eyes growing heavy, your attention drifting. There's something oddly soothing about contemplating the mysteries of the universe, isn't there? In 1896, physicist Wilhelm Wien, while grappling with the mysteries of black body radiation, found himself at a similar crossroads. His equations predicted an ultraviolet catastrophe, an infinite amount of energy at high frequencies, yet observation showed otherwise. Just like our vacuum catastrophe, the reality was at odds with the theory. Think about it. In your everyday life, you're brushing up against one of the greatest mysteries of our time. It's like Zeno's paradox, where the closer you examine it, the more elusive it becomes. The beauty of it, though, is that it doesn't disrupt your morning routine. You still get to enjoy your coffee, even as this cosmic riddle unfolds around you. What does this mean for you, for us, for humanity? It means we live in a universe that still holds secrets, that still beckons us to unravel its mysteries. It means that each cup of coffee, each seemingly mundane moment, is actually a brush with the extraordinary. By now, you may notice your breathing slowing, a sense of calm washing over you. Isn't it a comforting thought that even as we grapple with these existential questions, life goes on as usual? That's the grandeur of existence, the intertwining of the ordinary and the extraordinary. So, the next time you're standing in your kitchen, coffee in hand, let yourself marvel at the mystery of the vacuum catastrophe. Let your mind wander. Let your eyes grow heavy. Let the aroma of the coffee lull you into a state of peaceful contemplation. In the end, the morale of our story is this: the universe is full of mysteries, and it's these mysteries that make our everyday lives so wonderfully rich. We are a part of something bigger, something extraordinary. And as we unravel these secrets, as we push the boundaries of our understanding, we shape our collective future. So go ahead, enjoy your coffee, relish in the mystery. After all, who knows what revelations tomorrow may bring? Imagine getting up in the morning, brewing a fresh pot of coffee, and sitting down to enjoy the aroma and taste of your favorite blend. Now, imagine doing the same routine, but in reverse. The coffee going back into the pot, the water into the kettle, and the beans into the coffee grinder. Sounds bizarre, doesn't it? Welcome to the unsolved physics mystery of time's arrow. The time's arrow, or the arrow of time, is a concept that describes the one-way direction of time. It moves forward, never backward. From the moment you wake up to the moment you go to sleep, everything you do, see, or experience is influenced by this forward movement of time. It's as natural to us as breathing. But why does time behave this way? Why can't we brew our coffee in reverse? Let's break it down. the laws of physics, as we currently understand them, don't differentiate between past and future. They're time symmetrical. In theory, they should allow for the possibility of time running backward. Yet, this isn't what we observe in our daily lives. How could that be? Here's the crux. Sir Arthur Eddington, a renowned British astronomer, was the first to introduce the notion of an arrow of time in 1927. He proposed that the distinction between the past and the future, time's arrow, was linked to the concept of entropy or disorder. According to the second law of thermodynamics, the total entropy of an isolated system can only increase over time. In simpler terms, things tend to move from a state of order to disorder. This is why your bedroom gets messier over time if you don't clean it, or why your coffee disperses into the water instead of separating back into water and coffee grounds. Now think about the societal implications of this. If time could run backward, it would mean a reversal of cause and effect. We would remember the future and be blind to the past. How would society function without the certainty of consequence following action? From a more emotional standpoint, consider how time's arrow affects our personal lives. The irreversible nature of time is what gives weight to our choices. It's why choosing to spend time with loved ones feels meaningful, why we regret mistakes, or why we strive to make the most of our time. Yet the mystery of why time moves only in one direction remains unsolved. Some physicists suggest it's related to the conditions at the Big Bang. Others propose that it's an inherent property of space-time itself. The truth is, we don't know. But here's a takeaway. While we may not understand the arrow of time, we can appreciate its role in giving meaning to our lives. Our choices, our actions, and our experiences are all shaped by the forward march of time. It's what gives significance to our past, purpose to our present, and hope for our future. In navigating the river of time, we're all in the same boat, collectively shaping the course of human history with our everyday choices. So while physicists grapple with the mystery of time's arrow, let's remember to value the time we have, for it only moves in one direction. Imagine you're in a small town, nestled between rolling green hills and a sky so clear you can see every star winking in the velvet night. It's the sort of place where everyone knows everyone, where the humdrum rhythm of everyday life lulls you into a comforting routine. Now imagine this. One day, the whole town gathers in the local park, their eyes glued to the sky. A strange object, a spaceship perhaps, is hovering above their heads. The question on everyone's lips, are we alone in the universe? Or are we part of a bigger cosmic community yet to be discovered? This is the conundrum at the heart of the Fermi paradox. Named after the physicist Enrico Fermi, it's a question that has puzzled scientists for decades. Where is everybody? If there are billions of stars in our galaxy, each potentially hosting a habitable planet, then why haven't we encountered intelligent life yet? How could that be? Let's break it down. The universe is approximately 13.8 billion years old. Earth has only been around for about 4.5 billion years. So statistically speaking, there should be civilizations out there that are far more advanced than ours. Yet despite our best efforts, despite the millions of radio signals we've sent out into the cosmos, we've heard nothing back. Here's the crux. Either we're alone in the universe, or we're not. Both scenarios are equally terrifying. But what does this mean for our small town, staring up at a sky that might be teeming with life, or might be entirely empty. It's a question that carries emotional weight, tugging at our innate human curiosity. It's a question that makes hearts race, that makes eyes grow heavy with wonder. The very fabric of their reality, their place in the universe, is being questioned. As you sit with this thought, you may notice a strange sensation. A sense of smallness, perhaps, or a quiet excitement. Your attention might drift towards the stars above, their soft twinkling light a silent lullaby. Breathing slows, the world shrinks to the size of this town, this moment. Remember, societies have always been shaped by their understanding of the cosmos. From the ancient Greeks navigating by the stars to the space race of the mid-20th century, our perception of the universe has defined our collective identity. If we're alone, that makes us unique, special even. If we're not, that opens up a whole new realm of possibilities. Either way, we're part of a story much bigger than ourselves. A story written in the language of the cosmos. And so as the town's gaze remains fixed on the sky, a sense of unity settles over them. Regardless of the vast unknown, they're in this together. Whether we're alone or not, our actions, our choices, matter. They shape not just our lives, but the world around us, and perhaps even the universe beyond. As you reflect on this, you may find your eyelids growing heavy, a peaceful sleep beckoning. The stars above continue their silent vigil, a gentle reminder of the mysteries we've yet to unravel.